and just remember too, I have everything I'm going to record. So, we'll be putting up the recording later on today too. Okay, so, all right. Okay, so let's start with number 1. Let's go in some sort of order here. So we're talking about off the review sheet, right? Oops. Okay. So, oops, we got a second here. Okay, so we've got 1I, 1E, 1C, 1B. Okay, so all of the practice problems in part 1 are all about inverse trig functions. Okay, can you hear me now, Juliana? Okay. Okay, so they're all about the inverse trig functions. So let's first off talk about inverse trig functions here. So when we were dealing with the inverse trig functions, and this kind of goes with the domain of them. So you have, right, so if we think about the unit circle, the stuff in quadrants 1, so the inverse sine is defined in quadrant 1. The inverse cosine is defined in quadrant 1, and the inverse tangent is in quadrant 1. So if you're talking about inverse sine, inverse cosine, inverse tangent, you're going to be looking in quadrant 1. If you're talking about inverse cosine is in quadrant 1 and quadrant 2. And then inverse sine and inverse tangent are in quadrant 4. But remember, I'm going to put kind of a star here in quadrant 4 because the stuff in quadrant 4 we have to write as a negative angle. And so let me add in here our unit circle so we can kind of refer to that. Let me make it a little bit smaller here. Okay, so 1b, right, asks for the cosine inverse of root 3 over 2. So since we're talking about inverse cosine, we need to look in quadrants 1 or 2, and we need to look for, remember, cosine is the x value, so we're looking for where is the x value, root 3 over 2. So the x value is root 3 over 2 right here at pi over 6. So the answer to this first one is just going to be pi over 6. Does that help for the first one?
I have a question.
Sure.
So if it's a negative pi square root 3 over 2,
so if it was like the inverse cosine of negative square root of 3 over 2? So like that?
Yeah, would it be the other side?
Yeah, so if you're looking for, so again, inverse cosine is only in these first 2 quadrants. So now we're looking for where the x value is minus root 3 over 2. So that's right here at 5 pi over 6. Does that?
So all the inverses are in the first and second quadrant only?
Only inverse cosine. So it depends what it is. So that's what I just wrote here. Inverse cosine is in 1 and 2. Inverse sine, inverse tangent are in 1 and 4. So like somebody asked for 1e, and like 1c. So 1c is the, okay, so all right, so I've got a couple of people asking me questions. So remember, in the inverse trig functions, okay, not in the solving section, but when we get to the next section, not in the solving section, but on the inverse trig section only, right? In the inverse trig section, we are talking about, these are the only quadrants we look for. So I'm not going to give, somebody asked me, couldn't the answer also be 7 pi over 6? Because here the x is also negative. It's not 7 pi over 6 because if you notice, none of the inverse trig functions are defined here in the third quadrant. So even though, like, if we were solving an equation, it would be an answer, but in the inverse trig functions, we have to limit it to only one quadrant of positive stuff. So that's here, and then we pick one quadrant of negative stuff depending on whether we're dealing with the inverse cosine or the inverse sine or the inverse tangent. So if we're dealing with inverse cosine, anytime we're doing inverse cosine, we're looking at quadrants 1 and 2. Inverse sine, inverse tangent, we're looking at quadrants 1 and 4. And so you're not going to get something, in this case, it's not asking you to solve, so you're not going to get stuff in that other quadrant. Okay. So does that help at the beginning? I'm still going to do the other ones that people want me to go through. Okay, so 1C asks for the inverse tangent of 1. Okay, so remember, tangent, this is where something you might want to do on the test is you might want to take, I've done this before on these problems, right? You might want to take these values. And remember, tangent is y divided by x. So you might want to take all the y values and divide it by the x values. So if you do that, right, here, if I were to do that division, I would get root 2 over 2 divided by root 2 over 2, which is 1. This first spot here, I'd have 1/2 divided by root 3 over 2, so this first one's going to be 1 over root 3. And then this top one is going to be root 3. So those are going to be the values of the tangent. So I'm looking for when the tangent is equal to 1. And again, I'm looking in this quadrant and this quadrant. Tangent's going to be positive in the first quadrant. It's equal to 1 at pi over 4. So the answer here is just pi over 4. Kind of similar, 1E asks for the inverse tangent of minus root 3. So if we're looking for the inverse tangent of minus root 3, so again, if I did these divisions here, this would be minus 1 over root 3. This is going to be minus 1. This is going to be minus root 3. So the tangent is going to be negative root 3 here at 5 pi over 3. But when we're in the fourth quadrant, we don't write it as 5 pi over 3. We write it as minus pi over 3. So rather than when you're talking about the inverse trig functions, down here, 5 pi over 3 is going to be the same as minus pi over 3. 7 pi over 4 is going to be minus pi over 4. And 11 pi over 6 is going to be minus pi over 6. So we have to write those as negative angles. Only in quadrant 4. Yep. So I know I need to do 1I, which I'm going to here in a second, but questions on anything I just did, because 1I is slightly different. So it's not going to be 5 pi over 3 because only for the inverse trig functions, the way that we define the inverse trig functions, we have to write them as a negative angle. So if you're dealing with an inverse trig function and you're down here in the fourth quadrant, you have to write them as the negative angle, not as the positive angle, right? So the idea is, 5 pi over 3 usually goes all the way around this way, and instead we want to be going this way. So that's why we're going to make it minus pi over 3. Other questions? Okay, so before I do 5I, let me do one that's kind of similar to 5I, but a little different. So let's suppose that I asked for the inverse sine of the sine of pi over 3. So when you have an inverse function composed with the actual function, so like inverse sine with sine, like I have here, essentially what happens is they cancel out, provided that the angle you get is in the correct place. So if we notice pi over 3, right? Pi over 3 is in quadrant 1. It's up here. In quadrant 1, the inverse sine is defined. So that's fine. So in this case, these two things would cancel each other out, and we would just get pi over 3. Right? So they cancel each other out as long as they are in the right place. So now if you look at 1i gives you the inverse tangent of the tangent of 5 pi over 4. And so again, the inverse tangent and the tangent would cancel each other out. However, if you look, 5 pi over 4 is in quadrant 3. And quadrant 3 is not one of the ones that is defined for the inverse tangent. So what that means is actually to do this problem, I actually have to figure out the inside stuff here. So we're going to have the tangent inverse. So what is the tangent of 5 pi over 4? Yeah, tangent of 5 pi over 4 is 1. So we're really looking for the inverse tangent of 1. And so that is actually going to be here, right? Here's when the tangent is 1 at pi over 4. So in this case, the answer is going to be pi over 4. So if it's something that falls in the first or the fourth quadrant, or the second quadrant, depending if you have an inverse sine, inverse tangent, or inverse cosine, as long as it's in the right place and written the correct way, you can just cancel them out. That's probably wrong then. So, let me see what happened here. I might have, it's possible I might have either copied the problem down wrong when I did it, or... Oh, yeah, no, actually, yeah. Yeah, I did the problem wrong on the answers because in the answers, right, if you notice, I put that the tangent of 5 pi over 4 was -1, which it's not. It's a +1. So this is the correct answer. It shouldn't be negative pi over 4. So on these problems, like, there really isn't a ton of work to show, so you don't have to show work on just finding these inverse trig problems. There's plenty of problems on the test that there's work to show for, so. No problem. Any other questions on inverse trig functions before we go on to the next set of stuff? No? Okay. So for inverse sine of a sine, would it just be like the last one we just did with tan? So it depends on the problem, right? So if it was, there are two 1e's. What? Okay, wait a minute. Jade, can you write what the problem is for the other 1e? Are you talking about on a different sheet there's a 1e? Or you're saying that underneath where I put the solve and there's not the... Yeah, so I messed it up. So I messed up the numbering on the review sheet. There is a problem too. There is technically problems 1 through 5. You'll just notice under problem 1, there's a thing that says item, and then it says solve. That item was supposed to be problem set number 2. I forgot, because I type it in a program that, creates the numbering, so it should have said /item, and then it would have been 2, solve on the interval. So, yeah. So that's why they don't match up. So you want, okay, I can do that. The 2 cosine of 4 theta minus root 2 equals 0. I'll do that in a minute. Okay, so the question about here, if you have an inverse sine and a sine, right, if it was inverse sine and sine of 5 pi over 4, then yeah, you would have to do the same thing. If you're doing an inverse sine and a sine and it ends up in somewhere, the angle in here is somewhere in the second or the third quadrant, then yes, you have to do it the same way. If it's in the first quadrant, you can just cancel things out. So anything in the first quadrant, you can just cancel out. In the fourth quadrant, you can essentially cancel them out, but you need to make sure that you write the angle as a negative. Does that answer that question? I don't even remember. Okay, perfect. Okay. So let me write down, because a bunch of people put things in here to do. So I just want to make sure I have them all. So we did all the ones. So we still need, 2e. Somebody wants 5a. 1e, 3a, and 3c. 2b, c, d. Somebody wants square root of 3 cotangent theta plus 1 equals 0, which is h. Somebody also asked me. Okay, so that was another E one. I'm just scrolling back through to make sure I get everything. Okay, 2B. Okay, so I got 2B on here. Okay, so let's see, Katie, can you give another example of what to do if it's not in the right quadrant? Yeah, so if it's not in the right quadrant, you actually have to figure out the inside part and then figure out the outside part. So for instance, let's say it was the inverse cosine of the cosine of, say, 11 pi over 6, right? So, let me add in my unit circle here again. Okay, so inverse cosine is only defined first quadrant, second quadrant, right? So if I look at 11 pi over 6, 11 pi over 6 is down here in the fourth quadrant. So the first thing I'm going to do is just figure out the inside part. So the cosine of 11 pi over 6, cosine is the x value, so it's going to be root 3 over 2. So this is going to be the inverse cosine of root 3 over 2. And now I look in these two quadrants and see, okay, where is the x equal to root 3 over 2? Oh, it's equal to root 3 over 2 here, so pi over 6. So the answer here would be pi over 6. Does that help? No problem. And you can use it for things too. Like, so for instance, like I could have like the, say like the tangent inverse of the tangent of, say, pi over 12, right? So pi over 12 is not something that's on the unit circle. However, pi over 12, if you think about it, pi over 12, like this is pi over 6. Pi over 12 would be kind of like halfway in between here. So pi over 12 is in the correct quadrant. So again, these things would just cancel each other out, and this would just be equal to pi over 12. So as long as you're in the correct quadrant, you don't actually have to figure it out. You can just cancel stuff. Does that make sense? Okay. Yeah, another one of what type? From the not numbered row. Oh, the solve on the interval 0 to 2 pi type ones, Kelly? Yeah, I haven't done any of them yet. So all I've done so far is from number 1. So we're going to do a bunch from number 2 because a bunch of people asked me for like 2B, 2C, 2D, 2E. So we're going to do all those. Okay.
Question.
Sure.
So, if you're doing the ones that are exactly on the practice, can you do like different ones?
So, well, I think some of the ones that are exactly on the practice, people want me to actually like do those problems. So since they asked for them, but then yeah, I can do some after that are not exactly ones that are on the practice. Does that work? Okay. So the ones people ask me from the practice, so 2B. So 2B is, so, yeah, and I'm assuming, yeah, so they mean this. All right, so there's the first thing, before we even do 2B, the first thing I want to talk about is the way the instructions are written, okay? So the way the instructions are written gives you key as to what you have to find. So you're either going to see instructions for solving equations. You're either going to see solve, and it's going to say on the interval 0 to 2 pi, or it's going to say something like find all the solutions. And there's no interval given. Right? No interval given. So I want to kind of make this clear at the beginning. When you're asked to find problems on the interval from 0 to 2 pi, in this case, this is when you are giving answers from the unit circle. All right, so we're going to find the values on the unit circle. We're going to pick them off. When you're asked for find all the solutions, in that case, you're talking about, so the find all the solution problems, these are the ones where we had to add the plus 2k pi, where k is in z, okay? That's the difference between the two. So I just want to kind of put that out there, that there is a difference between those two, and so we want to be careful about what the solutions say. And so that is the difference. So if you're given the interval, you're talking about just picking off answers from the unit circle. In the problems where it says find all the solutions, then those are the ones where you have to add the plus 2k pi to the problems. Okay, the problems we're trying to do. Okay, so now, the problems in part 2 all say solve on the interval 0 to 2 pi. So 2b gives you 2 sine squared theta plus sine theta equals 0. So the first thing I notice here is that both of the terms, first off, everything's equal to 0. So I have all the important stuff on the left-hand side here. And then secondly, if I look, I have two pieces, and both of these pieces have a sign in them. So I could factor a sign out. So if I factor out a sign, I'm left with the sine of theta times 2 sine theta plus 1. Okay, so I figured that, but I figured some people also want to, some of the other ones from 2, because some people said things like 2C and 2D, and 2C and 2D are not, like, there is no C or D on it. So I'll do the stuff from my, what's supposed to be. I lost that, you guys. Wait a minute. What happened there? I lost my screen. I was going to say, my computer just went black, so give me a second. If you can still hear me, hopefully. Okay. All right. Oh, is my screen... Okay, let me see. Yeah, if my screen's lagging, you guys gotta tell me, because I've kind of over where I can't see the screen as I'm writing. Okay, so let me see. So let's see, equals 0. Yeah. All right, so let me stop sharing. And let me reshare. Okay, so let me add in here my unit circle. Okay, so let's look at 2e. Okay, so 2e gives us 2 cosine 4 theta minus root 2 equals 0. Okay. So, remember we're on the interval from 0 to 2 pi. Okay, so these are like the problems I did. Can we do 2 sine theta secant theta equals secant theta? Yeah, I can do that after this one. So 2 cosine 4 theta minus root 2 equals 0. So the thing to remember is that we're on between 0 and 2 pi. So the first thing I'm going to do is I'm just going to isolate the trig function like I've done in all these other problems. So I'm going to add the square root of 2. So we're going to have 2 cosine 4 theta equals root 2. And then I'm going to divide everything by 2. So we're going to end up with the cosine of 4 theta is equal to root 2 over 2. And so the thing here is that we are trying to figure out 4 theta. And so anytime you have an argument in here that's not just theta or not just x, usually what we want to do is we usually kind of set another variable. So we're going to let x be equal to 4 theta. So instead of solving the original problem, we're going to look at the problem of solving the cosine of x equals root 2 over 2. The 4, okay, what the 4 is saying, so if my original, if theta is between 2 pi and 0, that's once around the unit circle, right? Once, one unit circle. We are looking for 4 theta. So to get 4 theta, if I multiply everything by 4, we're talking about 0 being less than or equal to 4 theta being less than 8 pi, which means we're going around the unit circle 4 times around. Right? So that number in there is changing how many times you're going around the unit circle. So we need to go around the unit circle 4 times. Questions about that so far? We're still not done with the problem, but just questions about what's going on so far.
Where did you get the number 4 from?
It's from the original problem, so right in here. So it says 4 theta right in here. So that's where I got a 4. If this had been a 3, I would have done 3, 3, 3, and we're looking at 3 theta. If this had been a 1/2, I would have done 1/2, 1/2, 1/2. Whatever number is in here, that's telling you how many times around the unit circle you're going. So numbers bigger than 1 is telling you how many times around the unit circle you're going. Yeah, I would expect that there would be one problem, 1 or 2 problems where the angle is, I've changed the angle on you on the test. Does that help, Kelly?
Yeah, I got it. Thank you.
No problem. Okay, so we have to think about going around the unit circle. So the first time, so we're going around 4 times. So the first time we go around the unit circle, right? When is x equal to root 2 over 2? So on the unit circle, when is x equal, or when is the cosine of x equal to root 2 over 2? Okay, so pi over 4 And where else? Okay, so pi over 4 and 7 pi over 4. So those are the two places on the unit circle the first time around that the cosine of x is equal to root 2 over 2. So remember, if I go around, I guess, so that's one time around. The second time around, I'm going to stop at the same places. So I'm going to stop again at pi over 4, but this time I've gone all the way around once. So the next place that it's going to happen is at x equals pi over 4 plus 2 pi, or x equals 7 pi over 4 plus 2 pi. So that's the second time around. The third time I go around, right, I go around once, twice, and now I stop. So the third time I go around, x is going to be that original number, plus I've gone around twice now, so plus 4 pi, or x is going to be 7 pi over 4 plus 4 pi. So the number you're adding on is representing how many times around the unit circle you've gone around. And then that last time, x is going to be pi over 4 plus 6 pi, or x is going to be 7 pi over 4 plus 6 pi. Because that last time here, it's like I'm going around once around, twice around, 3 times around, and then I'm stopping. So I've gone 3 whole entire times around before I stopped. So I have all of these solutions. 4 times is pretty obsessive, right? It's a lot of times around. I probably wouldn't make you go around 4 times on a test. But the idea here is on the practice, right? It gets you used to the idea of having to go around. We have to actually figure out what all of these things are. So pi over 4, right? There's nothing to do with that. That's just going to stay as pi over 4. 7 pi over 4, that's going to stay as 7 pi over 4. These other ones, and I should have probably, oops, let me see if I can move this over here a little bit. I should have left a little bit of room because we need to figure out what this is. So pi over 4, to change this into, to add, so you can think of this as 2 pi over 1. So if I multiply the top by 4 and the bottom by 4 to be able to add the fractions. So we're going to have pi plus 8 pi. So this is going to be 9 pi over 4. And if you work out these other ones, you would get, so you'd have 17, this would be 17 pi over 4, and this one here would be, and again, the 17 pi over 4 I got by saying this is over 1, so times 4 on the bottom, times 4 on the top, so 16 plus 1, right? Same thing, over 1, times 4 on the top, times 4 on the bottom to make the common denominator. So this one's going to turn out to be 25 pi over 4. And then we have to do the same thing over here. So you're going to have 15 pi over 4 if you work this out. You're going to have 23 pi over 4. And again, 24 and 7 would be 31 pi over 4. So we're still not done. So, but questions on what I've done so far. Okay, good. I'm glad it makes sense now. Okay, so what I have so far, right, is right now I'm saying our x value is going to be either pi over 4, 9 pi over 4, 17 pi over 4, 25 pi over 4, 7 pi over 4, 15 pi over 4, 23 pi over 4, or 31 pi over 4. So right now, those are all the possible answers I have. Remember, x at the very beginning, or not at the beginning, but here we said x was the same as 4 theta. We really want to figure out our answers should be theta. So this is really saying 4 theta is equal to all these things. 4 theta is equal to pi over 4, 9 pi over 4, 17 pi over 4, 25 pi over 4, 7 pi over 4, 15 pi over 4, 23 pi over 4, 31 pi over 4. And now I want to find theta, so I need to divide each one of these things by 4. And when you divide them by 4, you will end up with theta equals pi over 16, 9 pi over 16, 17 pi over 16, 25 pi over 16, 7 pi over 16, 15 pi over 16, 23 pi over 16, and 31 pi over 16. So the problems on the test are not, this one I think is harder because it's so long. So there will be a problem on the test where you have to change the answer like this. I'm going to show you another one here when we go to the problems that are in like the next section. And I can show you that. So the denominator becomes 16 because let's look at one individual case. I don't know how many problems are off on the test off the top of my head. So we have pi over 4 divided by 4. So remember that's pi over 4. This is like 4 over 1. And so you're dividing two fractions. So you're dividing two fractions, keep, change, flip. So keep the first fraction, pi over 4, change the multiplication, flip the second fraction to 1/4. So that's why if I multiply across the top, I get pi. 4 times 4 across the bottom is 16. Does that help on why is the denominator 16? Okay. Questions on this one? Good. I'm glad it makes more sense. Okay. Does anybody need me to wait before I change to the next page? Okay. Somebody asked for part F, which is 2 sine theta secant theta equals secant theta. So any of these problems, I'm always going to pull all the trig stuff over to one side. So we're going to have 2 sine theta secant theta minus secant theta equals 0. And so this is going to be, if I factor out a secant theta, we're going to have secant theta times 2 sine theta minus 1 equals 0. And again, now I can split it into the two parts. So I can have secant theta equals 0. And 1 second, Brendan, I'll answer that. 2 sine theta minus 1 equals 0. Okay, so you can't divide by a trig function when you're solving an equation because what could end up happening is you could potentially end up losing solutions. In this particular problem, you wouldn't. So in this particular problem, yes, you could divide by the secant of theta because the secant of theta is never equal to 0. However, it's a bad habit to get into because if that secant was a cosine, all of a sudden you would have ended up losing information. And so you don't want to, it's just like how we don't divide equations, both sides of an equation by x. We're not going to divide both sides of an equation by a trig function. Does that make sense? Okay. So we're trying to figure out when is the secant of theta equal to 0. So remember, the secant of theta is the flip of the cosine. So this would be saying that the cosine is undefined, but the cosine is not undefined on the unit circle, right? The cosine is always defined. So the secant of theta equals 0, this never happens. So basically, we don't get any solutions from this first side. The second side, we have 2 sine theta, move the 1 over, equals 1. Divide both sides by 2. So we end up with the sine of theta equals 1/2. So where is the sine of theta equal to 1/2? When theta is equal to what? Yeah, pi over 6 and 5 pi over 6. So, and again, those are coming just off of the unit circle, right? So those are my 2 answers, pi over 6 and 5 pi over 6. And because I don't get any answers from that first piece, that is my total answer, right? So theta is pi over 6 or 5 pi over 6. Questions? No. Okay, so now if we look at the other problems that were, so the secant of theta, so remember, so let me put back in here, my unit circle. Okay, so remember, secant of theta is 1 over the cosine. So if you think about it, this would be the same as saying the cosine of theta is equal to 1 over 0. But that does not happen anywhere on here, right? This would be saying 1 divided by 0. That's when we say the cosine of theta is undefined. So there is no place on here, right? There are x values at all these places. So the cosine of theta is always defined. So there's no place where the cosine of theta is undefined. So the secant of theta can never be equal to 0. You could also remember the secant graphs, and that middle band of the secant graph was completely blank. So there was never a place where it was equal to 0. As long as in this problem, like if you kind of put it here, you don't have to write never happens or undefined. As long as you show me that you knew you had to put the secant of theta equal to 0, so I knew you tried to do it, then that's fine. There's not something specific you have to write. Okay, let me add in a unit circle again. Okay, so the problems that are in so on the thing it's labeled as 2, but I meant for it to be 3, but it basically says find all the solutions. And so let's look at B first. So this is what should have been 3B. It's not the 3B that's on the sheet, and we will talk about that here in a minute. So I have 2 cosine theta plus root 3 equals 0. So again, if I solve for theta, so I have 2 cosine theta equals minus root 3, divide both sides by 2. So the cosine of theta equals minus root 3 over 2. Yeah, so for the test, yeah, you need to write that the secant of theta equals 0. Yes, on that last problem. So if I look here at cosine of theta equals minus 3, root 3 over 2, the first thing I want to do is I still want to look for where does that happen on the unit circle. So where is the cosine of theta being equal to root 3 over 2 on the unit circle? Okay, so 5 pi over 6 and 7 pi over 6. Okay. That looks like a number sign, not a pi. So, all right. These problems you were not given an interval to begin with. So since you were not given an interval to begin with, these are the problems where you add plus 2k pi, plus 2k pi, where k is an integer. So if you're given an interval, you just pick off the values from the unit circle. If you're not given an interval, like in these problems where it just says find all the solutions, you have to tack on that plus 2k pi. That is the difference between what I meant to be problem number 2 and what is problem number 3. Questions? Okay, so yeah, so in Alex, there were problems that would have looked like this. If you don't write the k as in z, I'm still going to give you credit for it, as long as you have the plus 2k pi part. So let's say that, so this kind of ties into the last set of problems. So let's say there was one like the, let's say sine squared of, say 2 sine squared of, something different, 2 sine squared of 3 theta equals 1, right? So, again, the first thing I want to do is I want to figure out what the sine is, get the sine by itself. So we're going to have the sine squared of 3 theta, if I divide both sides by 2, is going to be 1/2. And then I have to take the square root of both sides. So I'm going to end up with the sine of 3 theta is equal to plus or minus the square root of 1 over 2. Or the sine of 3 theta, I should put parentheses there, is plus or minus 1 over root 2. And you could rationalize that. So this is really saying that the sine of 3 theta is plus or minus root 2 over 2. Right, so and I got root 2 over 2 by multiplying top and bottom by root 2, and I just did that so it looks like something on the unit circle. And now it's kind of similar to that last problem we did where we were talking about going around the circle so many times. However, in these problems, since it's a find all the solution problem, it's actually easier. So in this case, so again, we're going to let x be equal to 3 theta. So we're really looking here for when is the sine of x equal to plus or minus root 2 over 2. So when would that happen? When x is equal to what? Okay, so pi over 4. And again, because we're in this find all the solutions, we're going to have pi over 4 plus 2k pi. What else? Yeah, so pi over 4 plus 2k pi, 3 pi over 4 plus 2k pi. I'm going to move this up here a little bit so I have some more room. 5 pi over 4 plus 2k pi, and 7 pi over 4 plus 2k pi. Right? So those are going to be the 4 places because I'm looking for positive root 2 over 2 and negative root 2 over 2. And then I'm adding in that plus 2k over pi because this is the find all the solutions. Now, though, remember, my original problem was in terms of theta. So now I'm going to rewrite all these with my theta. So we're going to have 3 theta equals pi over 4 plus 2k pi. I'm going to leave a little bit of room underneath here. So, and I'll answer that question in 1 second. So equals 3 pi over 4 plus 2k pi. 3 theta equals 5 pi over 4 plus 2k pi. And 3 theta equals 7 pi over 4 plus 2k pi. So all I did was basically replace my, all I did here was replace my x's with 3 thetas because that's what x is. Okay, somebody asked me, why did I multiply top and bottom by root 2 over 2? You do not have to do that. I did that to make it look like something that was on the unit circle. So all of the bottoms of the things on the unit circle are a 2. And so if I multiply by root 2 over here, root 2 times root 2 will give me 2. And then on the top I have root 2. And so now I need to solve for theta. So to solve for theta, I'm going to divide by 3, which means dividing here by 3, dividing here by 3. Divide by 3, divide by 3, divide by 3. Divide by 3, divide by 3, divide by 3. Divide by 3, divide by 3, divide by 3. So this is going to give me theta equals, so pi over 4 divided by 3 would be pi over 12 plus 2k pi over 3. Theta equals 3 pi over 12 plus 2k pi over 3. Theta equals 5 pi over 12 plus 2k pi over 3. And theta equals 7 pi over 12 plus 2k pi over 3. So I actually think these are easier than the ones where you have to figure out how many times you go around the circle, because here it's just I solve it and then I just have to divide everything. Questions? For assignment 4, the questions are asked in quadrant 3, but the answer sheet shows the drawing in quadrant 4. Yeah, I typed that wrong, so it should have said quadrant 4. I'll fix the review sheet and put it back up. So for number 4, I'll fix that. Other questions. And some people asked me to do that problem, so I was going to do that one. So, 4 tells us the sine of alpha equals minus 15 over 17. The cosine of beta equals 3/5. And this should have said alpha and beta are in quadrant 4, not quadrant 3. And they want us to find A, the cosine of alpha plus beta, B, the sine of 2 beta, and C, the cosine, the tangent of alpha over 2. Okay. So the first thing, so first off, these things here, cosine alpha plus beta, sine of 2 beta, tangent of alpha over 2, these are all from that trig identity sheet. So off of the sheet, you can find the identity that says the cosine of alpha plus beta is going to be the cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta. And you can find off the sheet that the sine, I think on the sheet it's written as theta, so the sine of 2 theta is 2 sine theta cosine theta. So in our case, it's going to be 2 sine beta cosine beta, because we have a beta. Yeah, so you can keep the sheet with those identities. You could print it off if you want and keep it next to you on the test. I will also upload it with the assignment for the test, so it will be right there as well. And then the tangent of alpha over 2 is 1 minus the cosine of alpha all over the sine of alpha. So these things are coming right off the sheet. So all I have to do is plug in, but to plug in, I have to figure out what these are. I have to figure out what the sine of alpha, like I need to make a triangle from this part and a triangle from this part. So if we look at the triangle for alpha, so again, it should be in quadrant 4. So we're talking about the sine is negative 15 over 17. And if you use Pythagorean theorem, you can get that this turns out to be 8. And for beta, the cosine is 3 over 5. So 3, 5. And again, using Pythagorean theorem, you can find out that that is 4. And so then it's a matter of just picking these things off. So we're talking about the cosine of alpha. So that would be 8 over 17. Times the cosine of beta, which is 3 over 5, minus the sine of alpha, which is minus 15 over 17, times the sine of beta, which is, oops, and this should be a negative 4 over 5, right? So times negative 4 over 5, and if you work out, yes, you can use a calculator. And so if you work out what this is negative 36 over 85. Here, right, we're going to have 2. The sine of beta is minus 4/5. The cosine of beta is 3/5. So this is going to be negative 24 over 25. And then the tangent of alpha over 2. So we're going to have 1 minus the cosine of alpha, which is 8 over 17, divided by negative 15 over 17. I can multiply this whole entire fraction top and bottom by 17. So we're going to end up with 17 minus 8 divided by negative 15. Right? And so 17 minus 8 is 9. So 9 divided by negative 15, which is negative 3/5. Questions? No. Okay, and then so 5a gives you the cosine of 3 pi over 8 times the cosine of pi over 8. So again, you want to look at the sheet, and the sheet, if you have cosine alpha, cosine beta, they tell you that is the cosine of, actually, I should see where, the sheet is. Let me see what exactly is on the sheet. Or the way I have it written on the sheet. I just want to copy it the same way that I have it written. Second here. Your notes. Okay, so on the sheet, this one comes all the way down on the product to sum. And the way I have it written here is cosine alpha cosine beta is 1/2 cosine of alpha minus beta plus the cosine of alpha plus beta. So in this case, that's going to be 1/2 times, oops, I don't want to do it, switch back. Okay, so we're going to have 1/2 the cosine of 3 pi over 8 minus pi over 8 plus the cosine of 3 pi over 8 plus pi over 8. So we are talking about, I have 1/2 times the cosine of 2 pi over 8 plus the cosine of 4 pi over 8. So 1/2 the cosine of pi over 4 plus the cosine of pi over 2. So 1/2, so the cosine of pi over 4 is root 2 over 2. And the cosine of pi over 2 is 0. So this whole thing is just root 2 over 4. I lost my chat. Yeah, so I'll go back to the last slide in 1 second here. That's not a problem. I just want to make sure I got this one in since people asked for it before class ended. So if I go back here, okay. Okay, so let me see. Questions I missed. Will there be a problem on the test that... Oops. Will there be a problem on the test where we'll have to write which identities were used to solve a problem? No. So there won't be any like that. So there's no problems on the test that ask you to prove identities or ask you to say what identity was used. Other questions? No? Okay. The biggest parts of the test, just to kind of put this out there, the biggest parts of the test are, like, the biggest part of the test is the solving equations part. And I put up, there is more practice. So if you're like, I want more practice besides just what's on the sample test or on the practice problems for the test, there's another whole sheet for practice problems, dealing with the inverse trig functions. And there's another whole sheet dealing with practice problems dealing with, just solving equations. So there are more problems there to practice if you want them to practice. Is there anything else I can help? Let's see. For 5B, I got the solution of quadrant 2 over 2. Yeah. Part B, somebody sent me a thing. Somebody sent me a thing that, yes, that is wrong. It should have been, the sine of 30 is 1/2. So I will fix that on the review sheet and re-put that up as well. So the extra practice problems are the ones that are the biggest on the test. So the ones that are asking you to solve. So the problems that are asking you to solve are the biggest, that's the biggest component of the test. So solve either on the interval from 0 to 2 pi or find all the solutions. There are extra practice problems for both the inverse trig functions as well as the solving problems. And those two things together make up the bulk of the test. Other questions? Yeah. So by last slide, you mean this one, right? So, okay, so the problems like number 4, yes, you would be told what quadrant it's in. So the 2 pi over 8 came from, the 2 pi over 8 came from here. So my 3 pi over 8, this is my alpha, and the pi over 8 is my beta. And so when I plug them in, I did alpha minus beta. So I have 3 pi minus 1 pi all over 8. So 3 minus 1 is 2, so 2 pi's over 8. Does that help, Morgan? No problem. Any other questions? Okay, so it is 3:20. So, but if anybody has any other questions and wants to stick around, I'm more than happy to answer them. Or I also have office hours, so feel free to pop in on those. And then otherwise, I'll see you guys on Wednesday. If you're studying and you have questions, feel free to send me an email, right? If you find something on any of the sheets or anything like that, you're like, I don't know if this is right or not, feel free to send me an email. Okay. So this is actually an easier problem. So if we add the root 3 to the other side, so we're going to have tangent of 4x equals square root of 3. And then, now, so same thing like we did before. So we have an x, so I'm going to this time say this is theta. So this is going to be saying that, the tangent of theta equals square root of 3. And so now, when I have this, so I'm trying to figure out first, and our theta is equal to 4x. So when is the tangent of theta equal to square root of 3?
Pi divided by 3 and 4 pi divided by 3.
Right, so pi divided by 3 and 4 pi divided by 3. And then since this is the find all the solutions, we're going to add plus 2k pi plus 2k pi.
Yeah, that's what I got, but then on Alex it had just one solution.
Right, so now the thing is you have to go back to x's, right? So remember, theta is equal to 4x. So this is going to be saying 4x equals pi over 3 plus 2k pi. And 4x equals 4 pi over 3 plus 2k pi. And now we're going to divide each of these by, not by 4, we're going to divide by 4, not 3 here. So divide by 4, 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 divide by 4. So our final answer should be x equals pi over 12 plus, I could reduce this and get k pi over 2. Or x equals 4 pi over 12 plus k pi over 2.
But it said k pi divided by 4 in the answer which can add it.
Okay. Let me see. So which, this was on the, excuse me.
Sure.
Thank you. Was this on Alex or was this on the extra practice stuff?
No, this was on Alex. I was doing the assignment. I just wrote it down.
Okay. Let me see.
And it only gives like one solution. It gives only like
but did it? But it should have taken this for you. So Alex will just give one solution because in tangent, everything in tangent is off by pi. Like you can get from one value of let me add. Okay.
That's why I was confused because.
Yeah. So this is a totally. Yeah, this answer is totally fine, and Alex should take this answer. However, Alex gets clever, and what Alex does is, so we're looking for where it's pi over 3, right? So the thing is where it's root 3, which we said is here at pi over 3, and then also here at 4 pi over 3. So rather than write them as two separate answers at the beginning, what Alex does is it says, oh, well, you could just start at this pi over 3 and keep moving pi. And it's only tangents that you could do this for, so I don't teach it this way, but this is how Alex will teach it. So Alex, rather than write these two, Alex would have written this as saying, oh, theta is equal to pi over 3 plus k pi. And then you would have 4x equals pi over 3 plus k pi. So they would have divided everything by 4, and so they would have said x is just equal to pi over 12 plus k pi over 4.
You broke off like for one.
Oh, sorry. So what I'm saying is, so you, Alex would have written, combine these two. You can combine these two and write it as one as pi over 3 plus k pi, because you would just be hopping along this like plus pi, plus pi, plus pi, plus pi.
But what you did will be good.
But what I did is totally fine. Yeah, this is totally fine.
That's what I wanted to
Yeah,
say.
yeah. This is totally fine, and Alex should take this answer as well.
Okay, will we have questions like solve on the integral into 4 pi or 6 pi, like difficult things?
Mm-hmm.
Is there like a way we can practice more with those difficult problems?
There are some more in that extra practice sheets that I put up there.
Yeah, all of them I did, and I would.
So you can, if you want to go back to Alex, you can go back under review and go back to that topic where it's like it says the angle is not just theta, and you can keep getting, even though you've already done the topic, it'll let you back into that topic, so you can keep generating problems and trying them and then seeing if that answer is correct.
Okay, thank you so much.
No problem.
See you Wednesday.
Okay, sounds good.
Bye.
Bye.